We are Team Agasthya, and this is our solution for Theme 10, AI for Renewable Generation Forecasting for KREDL and KSPDCL. Our project, EASF-Net, is a forecasting layer for solar and wind energy. It predicts generation, shows how confident the forecast is, and explains the key reasons behind each result. Karnataka has strong solar and wind capacity, but renewable output changes quickly with weather and location. A forecast is not useful unless it is accurate, explainable, and usable for operations. That is the gap EASF-Net is designed to solve. It works alongside existing systems and helps operators plan day ahead, intraday, and hourly decisions with better confidence. So as we run this demo, I have made a small change. I had reduced the reinforcement learning training from 50 to 3 in terms of its episode number. And this keeps a full workflow visible and makes the demo fast. As the pipeline runs, first it creates synthetic renewable energy data. Then it trains the main forecast model and a second model that corrects forecast errors. After that, it estimates uncertainty, so we do not just get a prediction, but also a confidence range. This is important because in energy operations, knowing how uncertain the forecast is can matter as much as the forecast itself. Our model has been successfully trained. Now let's move on to the main dashboard. Here is the main dashboard. The blue line is the corrected forecast. The gray line is the base forecast, and the shaded band shows the uncertainty range. At the top, we can also see the corrected forecast value, the trust score, the interval width, and the recommended operational action. I can now test how the model behaves under changing conditions. If I increase the cloud cover, the forecast adjusts itself downwards and the confidence changes too. If I change the wind conditions, the wind-based forecast reacts immediately. This is useful because the model is not fixed to one asset or one location. It works at both plant level and cluster level, so operators can view as a single site or a whole region. Next is the explainability view. This shows which inputs had the biggest impact on the forecast. For example, cloud cover, irradiation, wind speed, and seasonality can all influence the result. This matters because operators should not only see a number, they should understand why the system produced that number. Coming to the operations view, the system summarizes confidence status, weather quality, model difference, and the recent forecast values. This is the practical layer for decision making. The engine view, we can compare the base error with the corrected error, which shows that the self-correction step improves performance. So the value of EASF-Net is simple. It gives forecasts, explains them, and shows how much to trust them. It is designed for real operational use, works alongside existing systems, and is built to handle uncertainty rather than ignore it. For Theme 10, our goal was not just to predict renewable generation, but to make the forecast useful for planning, scheduling, and grid stability. That is what EASF-Net delivers. Thank you.